There are two types of data structure. One is primitive and non-primitive data structure. The process of removing an existing data item from the given collection of data item is called deletion. There are three types of array. One is one-dimensional array, two-dimensional array, and multi-dimensional array. What is searching here? The process of finding the location of a data item in a given collection of data items is called searching. Welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our revision class with the chapter 4, that is data structure. Now, the weightage of the chapter is 14 marks, 1 MCQ, 1 3 marks question, and there are 2 5 marks questions. So, totally 14 marks. The weightage of the chapter is 14 marks. So, in this chapter, generally we are going to learn the definition of data structure, types of data structure, arrays, stack, queue, linked list, trees, and graphs. All these are examples for data structure. Now let us start with the definition of what is a data and data structure. As all of you know, what is a data? Data is nothing but a raw fact or collection of data, different types of data for processing. So the data is processed by the computer, that is data processing, and the result or information is the output of data processing cycle. So that is data. So in order to process the data should be organized in a particular way. This is leads to the structuring of data. So what is the importance of data structure? To process the data has to be organized in a particular way. That is the importance of structuring data. So what is data structure or structuring data? Here the data is arranged in a definite way for processing. Now, utilization of space by data in a memory and optimization of time taken for processing is an important rule in the data structure. So we have to arrange the data, or data has to be organized in a data structure so that the time taken for processing and also the memory space utilization is also an important factor in data structure. The data structure are efficient way of organizing the data, and it means organization or structuring a collection of data items in appropriate form so as to improve the efficiency, storage, and processing. So this is the data structure. It is organization of data or arrangement of data in a data structure so that it improves the efficiency in terms of time as well as in memory storage. So this is data structure. Now let us see what are different types of data structure, and this is a diagram or a picture, so we can see the different types of data structure. So a data structure is a specialized way or format for organizing and storing the data. Now here there are two types of data structure. One is primitive and non-primitive data structure. The primitive data structures are integers, floating point, character, pointers. These are called as primitive data structures. And non-primitive data structures, we have arrays, lists, and files. These are examples for non-primitive data structure. And again, under arrays, we have different types of arrays. One is single dimensional array, two-dimensional array, and multi-dimensional array. Now, if we talk about a list, we have linear data structure and non-linear data structures. So, under linear data structure, we have stack, queue, and linked list are example for linear data structure. And again, the trees and graphs are non-linear data structure. So, by looking at this diagram, it is easy for you to remember the examples and different types of data structure. Now let us see what are primitive data structure. So the data structures that are directly operated upon by machine level instructions are called as primitive data structure. So this is a definition of primitive data structures, and here the integer or real float and logical data, character data, or pointers and references are primitive data structures. So primitive data structures which works with the machine level language directly, and these are all the example for primitive data structure. Now non-primitive data structure, here they are more complex data structures. In the sense, these data structures are derived from primitive data structure. So what are non-primitive data structures? So these are type of data structures which are derived from primitive data structures. So here non-primitive data structures are classified as arrays, lists and files. So these are all example for non-linear data structure. Now in the next slide, say this is linear data structure. So what are linear data structures? So these are data structures or a kind of data structures that has homogeneous elements. Means each elements are referred by an index, and the linear data structures are stack, queue and linked list. So here linear data structures are a type of data structure, or it has elements of homogeneous elements. Means if I say homogeneous element, it means that it is a group of elements of similar type or similar data type. So example are stack, queue and linked list are example for linear data structures. In all this stack, queue and linked list, the data are arranged in a definite order. Now this is linear data structure. And in non-linear data structure, in which the data items is connected to several other data items. Example, trees and graph. So here, what is the meaning of this? Data item is connected to several other data items. So as we have seen in the previous slide, that linear data structure. So here, all the elements are connected to each other one to one, or in linear data structure, the elements are arranged in a definite order. Means suppose if an element is in position 0, next element is 1, 2, 3, 4, so on. See, that is the position of elements in linear data structure. But here in trees and graphs, example for non-linear data structures, here the elements are connected to more than one node or more than one data items. That is the meaning of non-linear data structure. Next, let us see what are the operations can be performed on linear data structures. So basic operations are nothing but the traversal. What is the meaning of traversal here? The process of accessing each data item exactly once to perform some operation is called traversing. So what is traversing? See, these are all different operations can be performed on linear data structure, where in linear data structure, the elements are arranged in a definite order in a sequence. So accordingly, what is the meaning of traversal? So the meaning is that accessing each data item at least once for different operations. So if I say different operations, it can be insertion, it can be deletion and so on. So we have to access elements of a data structure at least once. That is the meaning of traversal operation. Next one is insertion operation. So what is insertion operation? The process of adding a new data item into the data structure. So inserting a new item is nothing but insertion. It is one operation. Similarly, deletion. The process of removing an existing data item from the given collection of data item is called deletion. So insertion is inserting a new data item into a data structure, whereas deletion is removing a data item from the existing data structure. Next one is searching. What is searching here? The process of finding the location of a data item in a given collection of data items is called searching. So what is the searching? So here is searching for one data item in a data structure is called the process or operation searching. And here we are identifying that the particular item with its position or its location. Next one is sorting. What is sorting? Sorting is the process of arrangement of data items in ascending or descending order is called sorting. Arrangement of elements either in ascending or descending order is called sorting. It is one of the operations. Next one is called merging. Merging is the process of combining the data items of two data structure to form a single data structure is called merging. So here it works with the two data structure. If there are two data structures, so we are combining both the data structure to form a one single data structure, that is called merging. See, these are all different operations on linear data structure. Next one is we look into that. An array, it is an example for linear data structure. So here there are three types of array. One is one-dimensional array, two-dimensional array, and multi-dimensional array. In the next slide, we say what is the definition of one-dimensional array. So one-dimensional array is with only one row or one column is called one-dimensional array. So here, what does it mean one-dimensional array? Here, the data elements are arranged either in one row or in one column. It is called a single dimensional array, and we are accessing elements with single subscript, that is single dimensional array. And here elements are stored in a contiguous locations. Elements can be referred by its index. As all of you know, in index, so arrays, we are identifying the elements positioned by the index of an array. So these are referred by indexing. And how do we declare an array? The syntax is data type space name of an array with the size. Example, int a of 10. Int is a data type, a is the name of an array, size is 10. The meaning is that int is a data type, so it is an integer array, and there are 10 data items in it, so this is nothing but size of an array. And in the size, the always array index start with 0, so the last index is 9, that is indicate the size is 10. So it holds or it can store 10 data items. Similarly, double B of 10. Here double is a data type, B is the name of an array, and size is 10. So this is double array. So this is single dimensional array. So this is called single subscript. I mean, we are accessing the elements of array with one subscript. That is the definition of one-dimensional array. Now, how do we represent the element representation of one-dimensional array in computer memory? So, elements of linear array are stored in consecutive memory locations. Now, let's the example now. Let P be the location of the element. Address the first element of linear array. A is given by base address A. So, here to calculate the location of the address of the particular item in an array, so this is a formula. So a location of one particular item in an array or linear data structure in one-dimensional array, it can be found out by using the formula base A plus W P minus LB. So with the help of this formula, it is possible for us to find out the address of the data item in an array. Now this is how we represent or identify in computer memory. Suppose A, B, C, D is the elements of an array, and this is a location. Always arrays start with the address index 0. So this is the first index 0, 1, 2, 3 and 4. Here S says name of an array. So S says name of an array, and S of 0 indicates the first element A, B, C, D, E. And obviously, and all these are stored with, this is the memory address of a particular location or index of an array. So here, for example, 1000 is the address of first element, index 0, 1001, index 1, and so on. So with the help of the formula, A of 3 means I want to find out what is the address of S of 3, that is D. If I want to know that, it is possible to find out with the help of this address. So accordingly, 1003, it is the address of the element of the index S of 3. So this is how we represent one-dimensional array in computer memory. Now let us see the different operations on single-dimensional array or one-dimensional array. So first one is traversing, is as we have seen in linear data structure, same operations can be performed with respect to arrays. Traversing is accessing each element of an array at least once for doing any different operations. And searching is operation. It is finding the location of data items in an array, that is searching operation. And sorting operation, this is arrangement of data items of an array in a definite order, either in ascending order or descending order, is called the sorting. Next one is insertion. It is inserting a new data element into an array, that is insertion, and removing or deleting element from the existing array is called deletion. These are all different operations. Again, merging of arrays. So here it combining one or more arrays to form a single array or a single data structure. It is called merging operation. So these are all different operations can be performed on one-dimensional array or single-dimensional array. In the next slide, let us see what is the definition of traversing. And here, let us write an algorithm. This is an algorithm to find out or to perform traversing operation. So here, let A be a linear array with LB is a lower bound, UB stands for upper bound. And here, the algorithm is process is the operation to be performed. Here, this is a for loop. For location, lower bound to upper bound means index 0 is the lower bound, upper bound is the last element of an array. And process can be any operation, either insertion, deletion, or different operations. And A of location. So suppose A is the name of an array, A of location. So this is we are using in a for loop. So this is the traversing operations are nothing but accessing each element of an array at least once. So very good example this. For example, reading data elements into an array or reading values into an array and printing operation. So printing the elements of an array is an example for traversing operation. So this is an algorithm. In the next slide, let us see what is searching an element. So we know that it is finding the location of elements in a linear array is called searching. And here there are two methods of searching. One is linear search and binary search. These two are different methods of searching a data item in an array. Now next one is what is linear search. So the linear search is the simplest method in which the element to be searched is compared with each element of an array one by one from the beginning till the end of an array. So in linear search, the searching element, the element to be searched, it is compared with each and every element of an array from beginning till the end, from lower bound to upper bound. We have to compare the given search element with all the elements. Suppose if any one of the element is matches with any of the searching element, then we say that the element is present. So one of the method is linear search. Here the logic is we are comparing the search element with all the elements of an array from lower bound to upper bound. That is the definition of linear array. Another method is binary search. In binary search, it is applicable if the elements are sorted or the elements of an array. If it is sorted, the best method is binary search. So what is the definition of this? In binary search, the method compares the element to be searched within the middle element of an array. So here, first we have to find out the middle element of an array. So once the middle element is found, we are comparing the search element with the middle element. So if the element are same or is going to match with the middle element, then we can say that the element is present at that particular location. Suppose if element doesn't match or both of them are not equal, then we are searching for the elements from the right side of the middle element or the left side of the middle element. Again, we have to find out the middle element. So we have to keep on finding the middle element until the element to be searched for is found. So this is the logic for binary search. In the next slide, we see what is insertion element. Insertion refers to inserting an element into an array. And here when an element is to be inserted into a particular position, all the elements from the as-is position to the last element should be shifted into the higher order position. So what is the meaning of this here? So if I inserting an element into an array, now let us see with this diagram. See, suppose this is the original array, given array before insertion. So here index 0, 1, 2, 3, 4. There are 4 elements in an array. Suppose if I want to insert element 30. Suppose I want to insert element 30 at the position, this is element 30 at the position 2. Means we would like to insert 0, 1, 2. Here in this place, we would like to insert element 30. That is insertion operation. So here what we do is, see, as per the definition, from this point, so we have to keep moving the elements from here to the next higher order position. In that way, first here 60 is moving to next position, next come to 50, and you have to keep moving these elements to the next higher order position. So accordingly, here in this example, see, 40 is in position 2, it moves to position number 3, then again 50 was in position number 3, now it is in position number 4, and so on. So after this, we have to insert the given element at this location, that is S of 2, that is 30. So this is the process of this is the logic of inserting a new element into a single dimensional array. In the next slide, we see what are two-dimensional array. So a two-dimensional array is a collection of elements, and each element is identified by a pair of indices called subscript. So here in one-dimensional array, we are identifying the elements with only one subscript, a single subscript. In two-dimensional array, we are accessing or identifying elements with two subscripts or a pair of subscripts. Though here also the elements are stored in a continuous memory locations, and we logically represent the two-dimensional array as rows and columns. So in single dimensional array, as we have seen, the elements are arranged either in one row or in one column. But here in two-dimensional array, we are representing with number of rows or number of columns or more than one row and one column. That is how we represent in computer memory. So for here, two-dimensional array, it has m rows and n columns. So it is more than one column, and we are representing the index I and j. There are two indices, say in one index for rows and another index for j. And the number of rows and number of columns is a matrix, is called the order of the matrix, denotes m into n. Suppose if there are 2 rows and 3 columns, that is 2 into 3, that is the order of the matrix, or we say that is the m into n, or rows into column, for example 2 into 3, that is the order of this array. And the number of elements can be obtained by multiplying number of rows and number of columns. So in one-dimensional array, we can easily find out the number of elements in an array with the size. But here, what would be the size of this? Here, the size would be rows multiplied by number of columns. For example, if there are 2 rows and 3 columns, so 2 into 3 is 6. The size of two-dimensional array is 6. So here 2 stands for rows and 3 stands for column. So this is how to find out the size of two-dimensional array. In the next slide, see, this is how we represent two-dimensional array. In this example, this is row 0 or row 1, row 2, or we can assume that column 0, column 1, column 2. In this table, we can see there are 3 rows and 3 columns. So 3 rows and 3 columns, 3 into 3, 9. So it is possible for us to store 9 elements in two-dimensional array. Now, how do we access the elements of an array? With the subscript. Suppose A is name of an array, and here, suppose if I write A of 1 and A of 2. Here 1 stands for rows and 2 stands for column. So row 1 and column 2, so we are representing that is minus 3, that is equals to minus 3. So this is how we access the elements of two-dimensional array. Always first index stands for rows and second index stands for column. So this is how we access the elements of two-dimensional array. So this is how we represent in computer memory. Next we see representation of two-dimensional array in memory. And here it is possible to represent in two different methods. One is row major order and column major order. So these are the two ways or two methods we can represent two-dimensional array in computer memory. Now let us see what is row major order. So row major order is all the first row elements are stored in sequential memory locations, and then all the second row elements and so on. So here in row major order, so we know that it is in number of rows and number of columns. So here the first row elements are stored first, then second row elements, next third row elements and so on. So that is how we store the elements in row major order for two-dimensional array, and this is the formula to find out the address of or location of an element. With the help of this formula, if they are arranged in row major order. Now let us see now this is an example. Consider an array. This is two-dimensional array 3 into 3. The order is 3 into 3 is nothing but there are 3 rows and 3 columns, and accordingly this is one row elements and this is second row element, this is row third. So first row element, second row and third row elements, and in row major order we have to arrange this is the first, second and third. So in the diagram you can see that, see here, first one is assume that these are the memory addresses. If there are 9 elements, 2001 is the address of first element, that is 0, 0 is the first element, 0, 1 and 0, 3. Here 2, minus 2, 3. If you look at the example here, 2, minus 2, 3, I mean the elements of one row are arranged first. Next comes the second row, 1, 0, minus 3, that is 1, 0, minus 3 and 2, 2, 5. This is a third row element. And if you observe this address of this, so 0, 0, 0, 0, 0 is here, all 0 stand for 0th row, first row and second row, and these are all the column. So first row elements are arranged first, then second, then third row elements. So this is how we represent computer memory the elements which are stored in row major order. Now let us see what is column major order. So in column major order, all the first column elements are stored in a sequential memory location, and then all the second column and so on. Now how we have seen in row major order, first row elements are arranged first, then second and third row. Similarly in column major order, all the first column elements are arranged first, then second column and so on. Again, this is the formula to find out the address of the elements of a two-dimensional array which are arranged in column major order. Now let us see the same example here. So suppose this is a two-dimensional array with the order 3 into 3. There are 3 rows and 3 columns. 3 into 3, there are 9 elements. So in this example, observe this. First column 2, 1, 2 is the first column elements, minus 2, 0 is second column elements, 3, minus 3, 5 are third column elements. So this is how we represent in column major order. So here 2, 1, 2, it is first. Suppose assume that this is a memory address 2001, 2, 3, 4, and here these are the column. This is 0 is the first column, second column, and this is third column. So first column elements are arranged first, 2, 1, 2. As we have seen in the one, 2, 1, 2 is the first column, minus 2, 0, 2. Next is the minus 2, 0, 2 is the second, and so on. So this is how we represent the memory two-dimensional array which are arranged in column major order. Next concept is we will see what are the different applications of arrays. So arrays are used to implement such as data structures such as heaps, hash table, queues, and stocks, and so on. One of the advantages is that our applications is we are using arrays to represent different other data structures like stack, queue, and so on. And it is used to implement mathematical vector and matrices. So another advantage, applications, and many databases include one-dimensional array whose elements are records. So in a database, you know that database is a collection of records, and the records are represented by using one-dimensional or in arrays. So these are the applications of arrays. Advantages of an array, it is used to represent multiple data items of same data type by using only one single name. So that's a definition of an array. What is an array? Array is a group of elements of same data type or homogeneous elements and with only one name, that is name of an array. And it is used to implement structure like linked list, stack and queues and graphs. And two-dimensional array are used to represent matrices. That's what we have seen, two-dimensional array. What are the drawbacks of or disadvantages is that here we must know in advance that how many elements are to be stored in an array. So what is the one point here is disadvantage is that before, the programmer or the user must be knowing the size of an array in advance before processing. That is the one advantage. And it is a static data structure. Means, as we have seen in the declaration of an array, we have to declare the size in advance. As we know the size in advance, so once the size has been declared, we cannot change the size. Either we cannot increase or decrease the size of an array. That is the meaning of static structure. The elements of an array are stored in a consecutive memory location. So insertion and deletion is difficult and time consuming. And in an array, all the elements are stored in a sequence, the index 0, 1, 2 and so on. So the insertion and deletion, it takes a more time for processing. So students, so far in the revision class, we have discussed about data structures, definition, types of data structures with examples and arrays, single dimensional array, two-dimensional array and row major order, column major order, advantages, applications and disadvantages of arrays. Thank you so much.